Ford FE engine. Is it a 360, a 390, or some other variation? We don't know, but tonight we're gonna find out. Hey, welcome back to another episode of Cody Builds. On tonight's episode, we're gonna be tearing into our Facebook Marketplace FE engine, figuring out exactly what we've got. It's just about time to get this thing rebuilt. We need to get parts ordered, so I need to know, what is the bore size? Has a crank been cut before? We're gonna tear down this engine, go through it piece by piece, and figure out exactly what we need to order to rebuild this engine back to stock. Now, in order to help us stay organized, I've put together this little engine part organizer. We've got spots for our pistons and rods here. We've got spots for our lifters and our push rods. We can keep everything organized, so if the parts are all good, we can actually reuse them. We're gonna go through, inspect all the parts and pieces, keep them in order, and real quickly here, I'll show you exactly how I put this thing together. It's just a bunch of scrap plywood. It's 21 inches deep by 19 inches wide. It's wider than I really need, so I could throw my rocker assemblies up here as well as the cam. And I just made it out of scrap plywood, guys. I've got less than a couple bucks in this thing. Of course, you can buy these things online. They range anywhere from $50 all the way up to $300. We're really just gonna be organizing the pistons, rods, lifters, push rods, and the Valvetrain assembly up top here. Everything else we're gonna store in these cheap boxes I picked up from Harbor Freight. We're gonna label everything, including the hardware. Now, when I tore down the other engine block, the one that's been off at the machine shop, we just tore that thing down as quickly as I could take it apart. I didn't keep any of the hardware organized because that thing's gonna get all new hardware top to bottom. That's gonna be a high dollar build, and we really don't wanna cheap out on things like cylinder head bolts, oil pan bolts, stuff like that. So it's getting a whole new set of hardware. This engine, on the other hand, we're gonna salvage as much as we can because we're gonna be doing a budget garage rebuild on this thing. So we're gonna keep the hardware organized. We're only gonna replace critical components that need to be replaced. As we go along, I'll give you a few of the tips that I use to stay organized. Maybe they'll be applicable for your project down the line. Let's get into this thing. Let's start tearing it apart. All right, step number one here. This engine is full of oil, so we're gonna go ahead and pull the drain plug on this. See what the oil looks like. I can already see water. That's not a good sign. Hopefully that's minimal. Okay, just a little bit of water in there. Not too bad, actually. Because we've got this tilt engine stand, I'm also going to tilt this over, so we be sure to get as much of that oil out as we can. Okay, tilt this back up. And I'm actually going to throw the plug back in this. And now I'm going to pop the oil filter off of here. So next up, we've got the reason this engine was taken off the road. The guys that I bought this from said it was in a 1969 F100. The manifold cracked all the way through on this thing, and they said that's why they stopped driving it. I can already see it has one broken bolt here, and I'm gonna guess that the rest of these are gonna be pretty stubborn to get out as well. So right off the gun, we are going to hit these with some penetrating oil and some heat. And we're gonna see if we can't get these to break loose without breaking any more of them. I doubt that's gonna be the case, but we wanna try and get as many of these bolts out as we can, and then we'll go from there. If we have to, we'll weld some nuts on these studs and try and get them to turn out, or whatever we need to do to get these bolts out of the cylinder head. Feels like it's gonna twist off. Oh, yep. Popped right off. So I have a bad feeling that's the way most of these are gonna go. That one twisted off, so that's 0 for 3. Nope. 0 for 4. I had a bad feeling this was how this was going to start off. All right, we're going to change our tactic up here since the impact was instantly breaking them off. Go back to my leverage bar here. See if we can't work these loose. Hey, that one came loose right away, as did that one. Wow, that would have been nice up top. So we're going to get 2 of these bolts. Okay, that's not so bad. This bolt turned a little bit and then stopped. So what I'm going to do is rock this back and forth a little bit and see if I can't get a little more play out of it. There it goes. We got it worked loose. Nice. So we were able to get all 4 of these bottom ones loose. That's great. I thought for a second there I was going to be trying to remove 8 stuck bolts. It's just half. I think the reason these came out so easy and the other ones don't is these are open through bolts on the top, so it's easier for moisture to get down in here and crust up the threads really bad on these, whereas these are blind into the back of the cylinder head. At least that's my theory. And here you can see that manifold was cracked all the way through. So that's garbage as well. All right, well, I managed to snap 3 bolts off on the manifold on the passenger side and 4 on the driver's side. And I made a few attempts at getting them out, but they're being extra stubborn. So I'm gonna bypass that for now. We'll come back to getting those out later. Tonight, I really need to get this thing torn down and figure out what parts I need to order. So we're gonna go ahead and get the carburetor removed off of this bad boy. Now, the one thing we are gonna do when we put this engine back in is we are gonna put a 4-barrel intake back on this thing, and I'm intending to just find a cheap aluminum one, most likely. Probably like an Edelbrock dual plane, even a cheap Chinese one, honestly. We're not trying to make big power with this motor. We're just trying to get something reliable. Yes, the 2-barrel intake would work for that, but I kind of have bigger plans putting a 4-barrel intake and a 4-barrel carb back on this thing because eventually I may install the EFI system on this engine before we get to the big stroker motor. So I want to have that opportunity to do that, and for that reason I'll need a 4-barrel intake on this thing. All right, carburetor. Gonna cut this hose here. All right. Okay, next up, I'm gonna pull the valve covers here. All right, so I've got this cheap Harbor Freight box here. It's like 10 bucks, I think. It might have been on sale for even less than that. And this is what we're gonna store all of our bolts in for this build. I also have some stick-on labels here. So what I'm gonna do, I'm gonna mark on one of these labels, valve cover bolts, and I'm gonna say times 1, 2, 3, 4, 5, should be times 10. Okay, and I'm gonna peel this label and stick it right over the top of the compartment that I'm gonna put it in. So this is gonna sit over the top of this. I'm gonna take my 5 bolts, I'm gonna drop them right in there. The valve cover bolts are short, very obviously, so if I wanna add some other bolts in here, I can inventory what bolts are going in this compartment, put the number that are associated with that, and I should be able to distinguish between the shorter valve cover bolts and whatever else is in there. So we're gonna do that for all the bolts that we're gonna try to retain and reuse. And this will give us just a nice clean storage. We won't lose them, we'll know right where they're at, and we'll be able to inventory everything that goes in this box and everything that comes out of this box. Well, this is good. I'm not seeing anything immediately off up in the top end here. Everything's nice and tight. That's a good sign. Boy, don't know how often the oil was changing this bad boy either. Lots of sludge in the top of that valve cover. I don't see anything immediately that jumps out at me. So that's a good sign as well. So we're gonna keep moving forward here. We're gonna pop the intake bolts off of this. All right, I got all my intake bolts loose. The next thing I want to do here is get my rocker stands taken apart and pull out all of my push rods. Now, this is where our little organizer here is going to come into play, because we want to keep all these push rods lined up with the slot they're coming out of from the engine. So as it stands, this is the front of the engine. I've got this marked as front. Driver side, passenger side, front to back. We're gonna work our way back across the cylinder head, pulling the push rods out and dropping them in our slots here. And we'll keep the rocker stands set up on the same side as well. So we're gonna try and keep everything organized and in order here, because we want everything to go back where it's coming from. All right, these intakes weigh a legitimate probably 65, 70 pounds. So these things are not light. They're not easy to get off by yourself. So just take your time and understand that these things are insanely heavy, and watch your fingers. I recommend wearing gloves when you're doing this. All right, this is our first look inside the lifter valley. This all looks pretty darn good. There's a little bit of sludge up here in the front corner, maybe a little bit of moisture up in here that got into the lifter bores. It doesn't look like much. So I'm gonna go ahead and try and pry these up without doing any damage. And if I'm able to do that, I'll go ahead and I will pull the lifters out. Then we'll knock the cylinder heads loose. All right, the first lifter coming out looks fantastic, actually. Not even a little bit of wear on that thing. That's actually great news so far. I did soak all these bores down with penetrating oil, and that's kind of a key to get things lubed up so you're not just scratching everything when you're pulling it apart. It also takes a little bit of patience when you're talking about one of these older motors. You don't really know how well it was cared for. What I'm experiencing with these lifters is, what we're seeing is the lifters only travel a certain distance up and down. And what happens at the bottom of that travel is you get some oil buildup, and then it doesn't want to slide in and out of the bore of the lifter. So when I get this lifter pulled out, I'll show you exactly what I mean. So I'm just taking my time, I'm working the lifters up and down, trying to work that penetrating oil down below the lifter travel. Okay, so now this just pulled right out. If you see this dark ring around the bottom of this lifter, that's just oil buildup. The travel of this lifter is, you know, only as high as that ring. So that's where the lifter bore ends. And this thing's moving up and down and only going that high. You get this little bit of oil buildup, and the tolerances are so tight between the lifter bore and the lifter that even that little bit of buildup makes it difficult to get this pulled out of the lifter bore. So by adding that penetrating oil in there, you're giving it a little bit of lubrication, breaking down some of that buildup, and then you can slide it out without overly scratching the lifter. All right, we've got all of the lifters out of the bores. Now we can go ahead and knock the cylinder heads loose. So what you're gonna have is these bolts right here, 1, 2, 3, 4, 5 inside the cylinder head here, and another 1, 2, 3, 4, 5 on the outside of the cylinder head. So we'll take those 10 bolts off, and then we should be able to lift these cylinder heads off the block. All right, now we're going to take the pry bar, and I'm going to come under the front corner of the cylinder head here and just gently try to lift the cylinder head up. Okay, I'm just trying to break it loose there. Now I've got a bolt on the front edge. I'm going to lift off that. I'm just breaking the gaskets loose at this moment. We're not going too nuts here. Just trying to pry where I can pry, where I'm not going to destroy the cylinder head surface, and just knock that cylinder head loose. So again, here you can see we had a bolt set up for lifting the engine. So you can see we got that loose on this side. Same thing, we're gonna come up here, pry off the front bracket, just to make sure that's broken loose, okay? So now that we got the cylinder heads loose, I'm going to make myself a space on the bench here, because this is all going to live on the bench for now. Lift that off. First look inside the block. We got some junk in there. Cylinders walls don't look bad at all. Now, this side, we knew about this. This is the bad one. We knew there was water in this one. I think it's just surface rust. I did inspect all these cylinders, and I don't think anything's overly scratched in here. It's all just surface rust. So I'm going to clean this up first before we do any rotating or turning this motor over. I'm going to try and clean this up a little bit. See if we can't get a little penetrating oil down in there. Just get this lubed up so we're not scratching up the cylinder wall as we mess around with this engine further. All right, let's soak this thing down really good. I'm going to go ahead and shoot all these cylinders down with just a little bit of penetrating oil. It's not going to hurt. Better than rolling this thing over dry. All right, so there is a little bit of corrosion in that first cylinder over here. It's not awful. It's all confined really to the top edge of this. And it's not great, but I think it's enough that I can knock that down. The inside of this bore isn't awful. Now this corrosion does rise above where the ring travel is going to be. So I'm not going to know until I get a hone in here and start cleaning this up how bad it is exactly. But I really don't think it's anything overly nuts, especially considering the condition of everything else. I can just barely catch a fingernail. Yeah, I mean, anything else in here, I can't even catch a fingernail on anything else in this engine block. So really, we've got a really good base to start from. It's really just this one cylinder. And what happened here is the last guys that had this, for whatever reason, they pulled the spark plug out of the cylinder head. This engine sat outside, water got inside of it. This piston was up about 3/4 of the way, and it just held water right in here. And it's unfortunate, but it rusted just the inside portion of the cylinder wall. So I think for our purposes, for what we're trying to do, I think we're gonna be able to knock that out, get it nice and smooth in there without having to take too much material out. So we're really fortunate in that aspect. Now, here comes the fun part. We don't know what this engine is. I assume it's a 360. I was told it was a 360, but we do not know for sure. There are a couple stampings on this block. They say 352. What I know about Ford FEs, stampings on the block do not matter. The same stampings were used across multiple cubic inch engines that were all in the FE family. Now I'm going to show you how to measure the stroke of an engine. Really rudimentary way to do it, but a good way for you to identify if you've got a 360 or 390 or maybe some other Ford engine block. You can do this with the cylinder head on. You're just going to want to do it with a wood dowel. It's easier with the cylinder head off, obviously. You'll see why here in a second. We're going to drop a dowel down into that cylinder on top of the piston. The piston's all the way at the bottom of its travel. We're going to mark on that dowel where the travel is. Then we're going to run the piston all the way up and mark at the top of the block where that travel ends. And that's really all there is to it. We measure that distance traveled, and that's the stroke of the engine. So let me just show you now how that works. It's a really simple process. You can, like I said, you can do it. You can pull the spark plug. You can do it. If you're trying to buy an engine, you don't know what it is. 360s magically become 390s when they get pulled out of engines and they're for sale on Facebook. So this is a foolproof way that you can measure the stroke of your FE block and be certain that you're getting what is advertised. All right, so it's really straightforward. I don't have a wood dowel here, but this would work the same with a wood dowel that you can stick down into the cylinder with the piston all the way at the bottom of its travel. I know this is all the way at the bottom of its travel. I watched it. So you would put your dowel in, you'd mark at the top of the spark plug opening where that dowel is riding. So I'm going to actually redo this on this side. I got some black marks on the other side. I've got this all the way down and I'm marking it right at the top of the cylinder wall. Okay, so I got from there to there. You would then roll the engine over until the same cylinder, the piston is all the way at the top of its travel. Now, I don't necessarily need to do this because for my application, we can see that the piston is just below the top of the block, right? So essentially, really not much of anything there. But if you were working out of the cylinder head, you would then, once you knew the piston was at top dead center, you'd put a second mark and then you'd measure the distance between your two marks, and that is the stroke of your crankshaft. Don't know what this is. We're going to check. A 360 would have a 3.5 inch stroke. A 390 is going to have a 3.78 inch stroke. Okay, this is an extremely exciting find, guys. You tell me what that is. That's over 3.75 inches. That means this is a 390 crank already in this block. That is extremely exciting. I was not expecting to find that. This is in fact a 390 crank motor. I was actually trying to find a 390 crank so I could show you guys how to do a 360 390 swap. I was not expecting this at all, so I'm extremely excited about that. The next most important piece of information here is going to be the cylinder bore. We're expecting this, if it's stock, to be 4.05 inches, but seeing how we already know that this is a 390 crank when whoever had it before thought it was a 360, we want to see if this engine's been rebuilt. If it measures anything over 4.05, we know this engine block's been rebuilt. So I'm going to pull out a dial bore indicator. and we're gonna measure the bore of a few of these cylinders and see what measurement we get. All right, here we go, guys. I got a bore dial gauge, and essentially what I've got on here is 4.06 spacer. So the amount that this needle moves when we stick it in the gauge here in the cylinder wall is what we need to subtract from 4.06. So what we're looking for, I'm suspecting, is a bore of 4.05 inches. So what we would want to see or expect to see here is this to move to the 10. This is in 0.0005 gradients. So this 5 here is 0.005. This 10 is 0.010. So 4.06 minus 0.010 is 4.05. When we're doing this, what we want to do is we want to stick this gauge into the cylinder, and we just want to rock it back and forth. And we want to do that on the horizontal surfaces of the cylinder here, because you're naturally in a high mileage vehicle going to get a little bit more wear on the up and down stroke with the weight of the pistons down in the bore. So to get a true measure of what the original bore diameter would have been, we want to be rocking this back and forth on the inside here. Now I'm watching this and I'm seeing it go to about, that went to 009. And check this cylinder here. Same thing, it's going to 009. Watch the dial indicator here. We're gonna swing this. Oh, that's going right out to 10. Yep, that's 4.05 is what we're measuring there. Do the same thing here. All right, so this is the original bore. It's not been overbored. It's a 4.05 inch bore with a 3.78 stroke. That is indeed a 390 motor. So we have a true blue FE 390 here. I'm super excited about that. We are going to be using this engine in this truck, obviously, in Ellsworth to start. But down the line, we're going to be using this 390 in something else. So I'm super pumped that we've got a 390 here, that this thing's going to make a lot more power, should make a lot more power than a 360, especially when we get to the point of putting performance parts on it. So if we ever do any cylinder head porting or put a set of cheaper aftermarket heads on it than the trick flow ones I've got for the other engine, we can really pump up the horsepower in this thing on a fairly decent budget. So for now though, we're gonna go right back to stock. So it's important that we know that we are gonna stick with a stock bore, because we're just gonna do a gentle dingle ball hone in this thing to get a little cross hatching back in the cylinders. So we're gonna get a stock ring kit. And the next thing I need to know is if the crank has been touched at all. And this is going to be important because I can get the numbers off the crank and we can confirm if it is actually indeed a 390 crank. I anticipate it will be, but we've got to wait and see. So I'm going to go ahead and pull the accessories off. We'll catalog all the bolts for the accessories, pull the cam out, and then we'll pull the oil pan bolts off. Eventually we'll pull the rod caps, pull the pistons out, pull the main bearings, pull the crank out. We'll measure the rod and crank journals and just make sure that we have a stock non-cut crank so we know exactly what parts to order in this thing. Sweet Moses, look how loose this timing chain is. You guys think that was about ready to fail? This thing was probably primed to just a jump time. I can't imagine the racket that chain was making as well. So we're definitely going to need to replace that. All right, guys, you ready for the good, the bad, and the ugly? There's a little bit of all three here. First up, the good. We're gonna get in here, see this casting number right here, 2U, it's upside down, but that's a 2U on this crank. That is confirmation, that is a 390 crank. So I am probably the first person in history who has bought a 390 that became a 360 when it went up for sale. Almost every one of these 360s ended up becoming a 390 magically, but that's not the case here. I bought what I thought was a 360 and it's a 390. That is fantastic news. Higher compression, more power, more cubic inches, all good things. The bad. The bad is the main bearings and the rod bearings are shot in this thing. I'm gonna bring you in here. Let's wipe some of this oil off of this main bearing here. So wipe some of this oil off. You can see these are grooved. These are down to copper. They are ugly. Same thing, we're gonna move back here to another one. So that was the main bearings. Here's one of the rod bearings. I mean, the coating on these is completely gone. We're down into the copper. These are shot. So that's the bad. Now for the ugly. It's gonna be hard to see on camera here. The crank is very rough. The main journals especially are very, very rough, very rutted. That's because these main bearings are shot. They're gone. There's a lot of trash that's been put through these. I've not seen a ton of metal shavings, but I think this is just a high mileage, high wear situation. Now, the even worse is I went ahead and I used the micrometer here and I mic'd out the rod journals, the main journals, and took some measurements here. And what I did was I took 2 measurements on each of the main journals. And what I found was somewhere between 0.009 and a 0.0125 undercut from the factory. So I'm pretty sure the main journals on this have been turned down to 0.01 inches undercut from the factory. Then I went ahead and I mic'd the rod journals and I got basically the same thing. These are all really tight between 0.019 to 0.009, 0.0086 it looks like. So the rod journals are also undercut by 0.01 inches it looks like. So that's why we did this exercise, because I needed to see what the condition was of what the internals were. The good news, 390 crank. The bad news, it's already undercut and it's trashed. We could go take another 10 thousandths off, and that's probably what we're gonna do. We're gonna have to send the crank back out to the machine shop, have them clean up the main and the rod journals. I think by the time we get those cleaned up, it's not just gonna be a simple polish. I think they're gonna have to undercut those. It'll be a total of 20 thousandths undercut from what the factory crank was. That's okay, it's not that big of a deal. It just means that when we go to buy the rebuild kit, we're gonna have to buy the appropriate main and rod bearings. So those bearings are gonna have to be actually oversized by about 20 thousandths. We'll get the crank sent off to the machine shop. All I'm gonna have them do is turn the main and rod journals down. I'm not gonna have them do anything else. I'm not taking the block there. We're gonna do all the block work ourselves in-house. I was hoping we could just polish this out, but honestly, I mean, I'm sure you can, that you might actually be able to hear just how rough that is. That's not good. that's more than I can polish out. Because this 390 is going to go back into another project at some point in time, we don't want to just throw it together and trash out the bearings right away because we didn't take the extra step of having the crank turned down at the machine shop. So that's what we're going to do. I'm going to get the crank sent off. We're going to get into this block possibly this weekend before I send the crank off and just confirm there's no cracks, there's no nothing else going on here. I had a heck of a time getting the main caps off of this thing. They're very tight in the block here, so I don't know if the block core shifted at some point in time or something. We're gonna have to investigate, just make sure everything else looks good in this block. Now, the freeze plugs aren't pushed out or anything like that. There wasn't much for water in the block, so I'm not too concerned that about that. But I do just want to go through, inspect the whole block, make sure there's nothing else off. We're going to end up doing some of those oiling mods we did on the other block. We're also going to pull out all the galley plugs and get all the oil passages cleaned up, because with the bearings looking like that, the odds are there's gunk and crap in all those oil passages. We got to clean all that out, get all that looking fresh, and freshen everything up there. So we'll inspect the cam bearings, decide if we're going to replace the cam bearings or just roll with it. Now that I know that it's a 390, I'll probably put a mild cam in it. We'll throw a little mild cam in there, just give it a little bit of lope, nothing too crazy. But the fact that it's a 390 makes me want to do maybe just a little bit more than what we were originally planning on doing. It'll basically be close to a stock 390, just a mild cam, an aluminum intake, and a 4-barrel carb. That's really the plan for this thing. I'm going to go ahead and get cleaned up for the rest of the night, and that's going to do it for tonight, guys. Now, as always, if you don't work on your projects, they will not work on themselves. Thanks for tuning in. Keep building, and I'll see you on the next episode of Cody Builds.